So in this video, we'll look at the meaning of points of inflections on the graph of y equals f of x. And by definition, points of inflections are the points where the concavity of f changes. It essentially means that f double prime changes sign, because based on the previous video, we understand that the relation between the f double prime and the graph of y equals f of x is that when the f double prime has positive sign, the f of x is concave up. When f double prime has the negative sign, the f of x is concave down. So concavity changes means basically the f of x changes its shape to maybe from concave up to concave down, or from concave down to concave up. And mathematically speaking, it means we need to check the sign of f double prime. So of course there are two possibilities here. It's either from positive to negative or negative to positive for the f double prime. And we'll look at a couple of graphs to understand the meaning of the point of inflection slightly better. So for example, if you have this graph like this for y equals f of x, so please look at the current point here. You see, before this point, this shape is concave up, right? Concave up. And concave up means essentially f double prime is positive. And after this point, it becomes a concave down shape. So it's maybe the f double prime is negative. In that case, we call this point inflection, which is the point of inflection. And moreover, we can look at the second scenario. For example, it can be maybe something like this. You see, before this point, it is a concave down. And after this point, it is concave up, right? And it means most likely the f double prime is changes from negative to positive. So there's a sign change for the f double prime. And mathematically, if the graph is not given, if I'm asking you to find the point of inflections without looking at the graph, what you need to do is to compute the f double prime, the second derivative first, and then look at the sign table of the f double prime, right? So let's do an exercise on that. So please look at the current problem here. I'm giving you a function f. I'm asking you to find all the points of inflection. And based on what we said earlier, to find the point of inflection, you have to check whether the sign of f double prime is changed. So we need the sign table for f double prime. So let's do the calculation first. F prime is 4x cubed plus 12x squared. And accordingly, f double prime is 12x squared plus 24x. And to draw the sign table of f double prime, we need to set it 0 and solve for this. So we can solve it quite quickly. So x is 0 or minus 2. And then let's look at the sign table for this function. So if you look at the current sign table, of course, you are free to pick 2 points in each interval. We just need to check the sign of the f double prime. For example, for the first interval, you can evaluate f double prime at the point minus 3. For the middle interval, it's about the point, maybe you can choose something in the middle like minus 1. So you need to evaluate f double prime as minus 1. For the last one, you need to evaluate maybe a point bigger than 0, f double prime is 1. So this evaluation will give you the following calculations. So the first value would be 36, which is positive. The second value is negative 12, which is negative. The last value is 36, which is positive. So I put the sign in positive, negative, positive like this. And as a good habit, you can draw the concavity of f directly based on this table, like concave up, concave down, concave up. And now you see there are 2 points where the sign change occurs for the f double prime, right? So the first point is x equals minus 2 is a point of inflection. The second point is 0, which is also a point of inflection. So we can make the final conclusion here. So basically, there are 2 points of inflections. And for the first one, you need to evaluate f of minus 2 based on the original function f. And it's going to be minus 2 and minus 17 as the point. And for the last point, you see, please recall f is x to the power 4 plus 4x cubed plus 1, right? Minus 1, I'm sorry. So it means that this point is 0 and minus 1 when x is 0 for the function f. And that's the final answer to this problem.